Hi, in this video we're going to look at how we go about finding the square roots of complex numbers. We'll start off with a simple problem and then we'll build it up a bit. So I want to find out what is the square root of 8i. I'm anticipating that this is going to be some complex number. So I'm going to say let the square root be this number a plus bi. So in other words, I'm saying over here, a plus bi is equal to the square root of 8i. In which case I could square both sides and I'll have a plus bi all squared is equal to 8i. So if I multiply out my left-hand side, I'm going to get a squared plus 2ab, don't forget that a, plus 2abi plus bi squared is equal to 8i. Now, bi squared is simply going to become a squared minus b squared plus 2abi, and that's going to equal 8i. Now I'm going to need a bit more space for this. Now, this is the real component, and this is the imaginary component. And although we don't see it, we don't write it down, the real component for this number is 0. So in other words, I can say that a squared minus b squared equals 0. And I can also say that 2ab is going to equal 8. So I've got two unknowns and two equations. So let's go about working these simultaneously. I want to work out what a is first of all, so I'm going to rearrange this equation and say, right, b is going to equal 8 over 2a, or in other words, 4 over a. And I'm going to substitute b is equal to 4 over a into a squared minus b squared equals 0. So I have a squared minus 4 over a squared equals 0. That's going to give me a squared minus 16 over a squared equals 0. Now, that's a bit of a messy equation, so I'm going to multiply everything through by a squared. See, I missed a squared out over there. I'm going to multiply everything through by a squared, so I'm going to get a to the power 4 minus 16 is equal to 0, in which case a to the power 4 is equal to 16. And that means that a is going to equal plus or minus 2, because 2 to the power 4 gives me 16. So again, giving myself a bit more room over here, I can now go back and say, right, if a is equal to positive 2, then b is going to be 4 over 2, which is 2. If a is equal to negative 2, then b is going to be 4 over negative 2, which is negative 2. And that means I have my two roots. The square root of 8i, we said, was this number a plus bi. So in other words, the square root of 8i is either going to be 2 plus 2i or minus 2 minus 2i. And so there I've got the square root of 8i. When I come to deal with the next example, we're going to approach it in a very similar sort of way. Again, clearly I'm going to need a lot more space than I've given myself before. So I want to find the square root of 3 minus 4i. Again, I'm going to start off and say this is going to be some complex number. Let's call it c plus di. And so c plus di all squared is going to give me 3 minus 4i. And now I'm going to have c squared minus d squared plus 2cdi, and that's going to equal, I don't know why I made that 4a, it should be 4i. That's going to equal 3 minus 4i. I can see the real component over here, and I can see the imaginary component over there. So I can say c squared minus d squared is equal to 3, and I can tell 2cd is going to equal minus 4. So once again, if I try and solve for c, because that is the real component, I'm going to do that part first. I can say over here that d is going to equal minus 2 over c. I divide both sides by 2c, and I then go and substitute d is equal to minus 2 over c into my equation c squared minus d squared equals 3. I am then going to have this, I'm going to have c squared minus 2 over c all squared is equal to 3. That leaves me with c squared minus 4 over c squared is equal to 3. Now, when I go and expand this out, I need to get rid of the fraction. So I'm going to multiply everything through by c squared. So I'm going to get c to the power 4 minus 4 is equal to 3c squared. And if I bring everything to one side, I'll get c squared minus 3c, sorry, not c squared, c to the power 4, c to the power 4 minus 3c squared minus 4 equals 0. And that has a quadratic format to it. In other words, I can factorize it. I can factorize it as c squared minus 4, c squared plus 1, in which case c is either going to equal plus or minus 2, or c is going to equal plus or minus the square root of minus 1. Now I just have to be careful here when working with this, because I could clearly see at the start over here that c was a real component. And if I've got over here that c is plus or minus the square root of minus 1, I'm going to have to reject this, because that would mean that c wasn't a whole number, a real number. It would be a complex number, and so I'm going to reject that. So in other words, when c is equal to 2, then what did we have? We had that d was going to be minus 2 over 2. Why did I put c? Should be 2. And that's going to give me minus 1. And if c was equal to minus 2, then d is going to be minus 2 over minus 2, which is equal to plus 1. And so here I have my two solutions. I'm going to get that z is either going to be 2 minus I or 2 z is going to be 2 plus I. And those are the two square roots of the number 3 plus 4i. Square root of 3 plus 4i is going to equal plus or minus C was minus 2, plus or minus 2 minus I. Right, that's all for this video.